today we will give you a really good presentation from the three different persons. One of the connect to us from the live from USA, and others to two young scientists from Turkey, which is very valuable for us. But firstly, I will shortcut. Firstly, we will present two different curious science videos to you: the unknown secret of thermodynamic and mutation of the virus. Thank you very much. That's beautiful for sure, of course. Thank you very much. Thank you very much for this video. Now, let's move on the next session. Boray Güvenç is the young scientist from the Bilkent University, give us a presentation about the unknown secret of thermodynamic and mutation of the virus. So, Mr. Güvenç, here's the word is yours.
Okay, thank you, teacher. Hi everyone, my name is Boray Güvenç, and as my teacher said, I'm from Bilkent University in Ankara. Today I'm going to present you the arrow of time. If you can see my screen, can you thumbs up, please?
We can see your we can see your screen and we can hear you very well. Don't worry about it.
Okay, no problem. By the way, okay, let's have a start with a simple question. Wait a second. Okay. My first question. Let's ask ourselves. As everyone knows, heat goes hot things through the cold things, but why it does not does heat go from hot things to cold things and not vice versa? This is our main question, and to explain it better, I wanna show you a brief story about James Maxwell and Ludwig Boltzmann. Until the mid-19th century, physics attempted to understand heat by thinking of it as a kind of fluid called caloric, or two fluids, one hot and one cold, actually. The idea turned out to be wrong, and eventually James Maxwell and the Austrian physicist Boltzmann understood the situation. And today I'm gonna focus on Boltzmann's theories. And what they understood is really beautiful, strange, and profound, and takes us into regions which are still largely unexplored. Okay, let's continue. What they came to understand is that a hot substance is not one which contains caloric fluid. A hot substance is a substance in which atoms move very quickly, actually. And atoms and molecules, small clusters of atoms bound together, and they are always moving. They run, vibrate, bounce, and so on. Cold air is air in which atoms, or rather molecules, move more slowly. But as you know, hot air is air in which molecules move more rapidly, actually. Beautifully simple, but it doesn't end there. As everyone knows, we know that heat always moves from hot into cold. As we see in this picture, left picture, a cold teaspoon placed in a cup of hot tea also becomes hot. We know that. If we don't dress appropriately, like me, on a freezing cold day, we quickly lose body heat and become cold. Why does heat go from hot things to cold things and not vice versa? This is our main question, and I want to mention it again here. Let's start with our main topic. It's a crucial question because it relates to the nature of time. Yes, you heard me through the nature of time. In every case in which heat exchange does not occur, or when the heat exchange is negligible, we see that future behaves exactly like past. Future behaves exactly like past. For example, for the motion of the planets of the solar system, heat is almost irrelevant, as we can see in the picture behind writings. And in fact, the same motion could equally take place in reverse without any law of physics being infringed. Let's continue. As soon as there is heat, however, the future is different from the past. While there is no friction, for instance, you can watch my camera, a pendulum can swing forever. It cannot stop if there is no friction. If we film it and run the film in reverse, we will see movement that's completely possible, like my finger. But if there is friction, then the pendulum hits its support slightly, loses its energy, and slows down like my finger, as you can see. Friction produces heat. This is really important. And immediately, we are able to distinguish the feature towards which the pendulum slows from the past. This is the main difference between feature and the past. This is very important. We have never seen a pendulum start swinging from stationary position. It's not possible because this is not natural actually. With its movement initiated by the energy obtained by absorbing heat from its supports. Okay, so this is our main topic. The difference between past and future only exists when there is heat. The fundamental phenomenon that distinguishes the future from the past is the fact that heat passes from things that are hotter to things that are colder. And again and lastly, why, as time goes by, does heat pass from hot things to cold and not the other way around? Okay, and right now I will explain it here. The reason was discovered by Boltzmann, as I mentioned before in my first page, and it was surprisingly simple. It is sheer chance. Boltzmann's idea is subtle and brings into play the idea of probability. Yes, you hear me through probability. Heat does not move from hot things to cold things due to an absolute law. It only does so with a large degree of probability, as we can see from the picture. The reason for this is that it is statistically more probable that a quickly moving atom from the hot substance collides with a cold one and leaves it a little of its energy, rather than vice versa. This is the main reason behind it. Okay, and energy is conserved in collisions, as we all know, but tends to get distributed in more or less equal parts when there are many collisions. In this way, the temperature of objects in contact with each other tends to equalize. Yes, they are tends to equalize. And it is not impossible for a hot body to become hotter through contact with a colder one. It is just extremely improbable. Yeah, it's all about probability, as I mentioned before. And lastly, and sadly, this bringing of probability to the heart of physics and using it to explain the basis of the dynamics of heat was initially considered to be absurd. As frequently happens, no one took Boltzmann seriously. This is the main problem for all scientists. In their generation, they cannot find an exact way to introduce themselves, and finally, some problems may occur. And in 1906, he committed suicide by hanging himself, never having witnessed the subsequent universal recognition of the validity of his ideas. If you like my topic, you may read 7 Brief Lessons in Physics. This topic is explained better than this slides. Thanks for listening me. Goodbye.
Thank you very much. That was a great presentation. Thank you very much, Burak Güvenç. He is the most lightning scientist and youngest scientist in Turkish, and he's going to the very valuable university right now. Thank you again, Burak Güvenç, again. So we will continue with another video. It's about the mutation of the virus, which is the occur right now in the world and stuck in the home. So it's make us very sad. So let's continue with our videos, mutation of the virus. Thank you very much. Mr. Çelik, you may move on with the video. And now we will continue with the Ulaş Mutlu from the one of the best university in the Turkey, Middle Eastern Technical University, and he will talk about the mutation of the virus right now, which is very important in these days, especially for the people. So, Ulaş, we are on you. You may start if you want.
Okay. Can you hear my voice and
Yeah,
presentation properly?
we can hear you proper, and we can see your screen too. You may move on. You may start.
Okay. Hello, everyone. My name is Ulaş. As Mr. Gezici mentioned, I'm studying at Middle East Technical University, and today I'm going to present my presentation about mutation of viruses. So let's start with the contents section. At first, I will explain, to better understanding, I will explain the evolution firstly, before the mutation. And after that, I will explain why mutation related with evolution. And then I will talk about mutation of viruses basically. And after then, specifically, I will talk about SARS-CoV-2, aka coronavirus. And lastly, I will answer some questions about some rumors about SARS-CoV mutation. So let's start with evolution part. What is evolution? In terms of biology, evolution is an alteration in characteristics of species over several generations. And some characteristics may give the individual an advantage and feature and different kind of things to compete with external and extreme conditions. And these characteristics can pass their offsprings with next generations. In terms of biology, theory of evolution says that evolution happens with natural selection. Thus, we can consider that the evolution is a survival mechanism, basically, and to survive in unstable and extreme environmental conditions, species should be changed based on some principles like adaptation and mutation. And today I will talk about the mutation part of evolution. Right now you can observe an image of evolution. It's a quite common image. You can see your in biology course book. And this I love this image actually. Let's continue with the mutation of viruses. What is mutation? Mutation is basically an alteration in genome of DNA, and mutation can be result from mistakes made during cell division. It can be with exposure to ionizing radiation, exposure to chemicals called mutagens, or infection by viruses. There is a great scientist for great geneticist from United States from America, Francis Collins. Let's listen his audio about mutation.
Mutation has been the source of many Hollywood movies, but it's really a simple process of a mistake made in a DNA sequence as it's being copied. Some of that's just the background noise that DNA copying is not perfect, and we should be glad of that, or evolution couldn't operate. But mutation can also be induced by things like radiation or carcinogens in a way that can increase the risk of cancers or birth defects. But it's pretty simple. It's basically an induced misspelling of the DNA sequence. That's a mutation.
if you did hear the Mr. Collins audio properly, he mentioned a misspelling, a mistake. And these mistakes can cause different alteration in future, and this cause a change from characteristics of some genetic materials. So these misspellings allows the species to alter their future to adapt different and extreme conditions by a mistake, of course. And also these mistakes can be inherited by next generations of that species. After we talk about the mutation, we can continue with
Mutation has been the source.
mutation of viruses. There's a picture of the coronavirus. You can observe. Mutation of viruses can made with changes, as I said. The changes is a keystone of mutation, and this statement is valid for viruses either. The viruses mutate itself just to evade the immune systems of species, because everybody knows viruses need to host to maintain their kinds with species. So some type of viruses doesn't have to ability to infection to humans or spread interspecies, but with mutation it allows to infect the humans by other animals and species. They gain the ability to infect humans. For example, influenza viruses, as we know as flu viruses, normally is bird-induced viruses, but it can infect humans. So they gain ability with mutations to infect humans. And another example for this mutation for spreading is in SARS-CoV-2 virus. Because normally SARS-CoV-2 virus is for pangolin animals. But however, with a mutation, it can be transmitted to pangolin to human. Also, normally coronavirus family are associated with mixed and domestic cats, but with mutations, they can be affect other animals and humans as well. So there is a chart, there is a structure with human and bird viruses. To better understand, I will explain this picture. In right side of the chart, up right, of course, there is a human virus, human variant of coronavirus. Excuse me, influenza virus. And left side, there is a bird variant of influenza virus. Normally, the bird variant can't affect humans, can infect humans. But if they mutate with human variant of virus, they can came together a better new highly pathogenic bird and human virus. It can affect both humans and birds with a mutation, and this mutation can inherited by new generations. So it's a quite common thing in virus world. Also, you can observe a table for to better understanding to mutation of viruses. You can see group A is a influenza virus family caused by birds, and in group B you can observe influenza virus family caused by pigs. as a percentage, I will explain the classes. In 48% of influenza viruses caused by birds, with mutations can cause infections in humans. And in percentage of 62, it can infect other species. But just a little percentage of the influenza viruses caused by birds can affect only birds, like 38%. Also, another percentage chart in Group B, we can talk about 23% for humans to infect caused by pigs influenza viruses, and 55% of influenza virus caused by pigs can infect other species. Just 45% of this virus caused by pigs affects same species of the pigs. So let's continue with the mutation of SARS-CoV-2 especially. You can observe an image about mutations and spreading chart for coronavirus family. Normally, coronaviruses spread in domestic cats, pigs, and other other animals. But with mutations, it can affect humans. We observed some pandemics and epidemics caused by coronavirus mutations. Before the mutation of MERS and SARS in 2004 and 2006, MERS only affect camels, and SARS-CoV-1 in 2004 just affect domestic cats. But with mutations, they started epidemics in China and India in 2004 and 2006. And as everybody knows, in 2019, SARS-CoV-2 virus mutated with pangolin, and they transmitted pangolin to humans, and they started a pandemic, unfortunately. You can see other viruses, they are not relevant for us. So let's continue with SARS-CoV-2 mutations. When SARS-CoV-2 spread around the globe this year, scientists wondered how the deadly virus behind the pandemic might be altering as it passed from animal to person. Of course, by a mutation, SARS-CoV-2 gained ability to transmit animal to human, and it gained power to spread faster. And today, SARS-CoV-2 keep on mutating itself just to overcome human immune system. But it is a normal thing for viruses because it is part of evolution. Some people were worried with that situation, and some people say mutated virus can be spread faster than the common one. Some people say the mutation will affect the vaccine improvements, and the pandemic will extend their end time. So let's ask 3 questions and answer them. Should we really scared of mutation? Is mutation really affect the spreading speed? And lastly, is mutation affect the vaccine improvements? So let's continue with answer of these questions. Also, you can observe an animation of coronavirus. Start with first question. Should we really scared of mutation of SARS-CoV-2? Before we discuss mutations' bad effects, we should know coronavirus mutations are extremely natural, and it is part of the evolution process. Scientists say even mutation can change the spreading speed of virus. This mutation have not been strong enough to affect the course of the pandemic in a good way or bad way. Also, mutation did not change the course of the disease with noticeable clinical effect among those who contracted the virus. So basically, we don't need to scare of the mutations. It is normal. But we can say the same thing for the affection of the mutation to the vaccine improvements and the cure of the infection. But even if we can say anything accurate about the last news, we should think that later on, after this studies about the mutations of SARS-CoV-2, because there is no accurate studies for the new mutations of these viruses. So that's the end of my presentation. Thank you so much to listen to my presentation.
Thank you very much. That was a great presentation. Ulaş Mutlu from the Middle Eastern Technical University in Ankara, and he is a very valuable young scientist. Thank you very much, Ulaş.